Okay, good morning, everybody. Hope you guys are doing well. Hopefully, you didn't think that quiz was too difficult on Monday. So, today we are going to finally start into a little bit of new information, and we're going to start by covering chapter 0, section 2. And in this chapter and section, we do a couple things. We learn about classifying numbers as well as writing some fractions out. So, let's get started. The first thing that we need to discuss is how or what the different classifications are for numbers. And what I want you to see is how this picture is organized. And what that means is if you would put something into this cone right there and it would qualify as a natural number, then it will qualify as almost every other one after that. So if you put something in this cone, it would be a natural number, then it would go into the whole numbers, then it would be an integer, then it would be a rational, and then it would be a real number. The only one it would skip would be irrational. So as you go and you classify numbers, depending on where you put that number in, for instance, if it went into the integer pile, if it's an integer, then it would also be a rational and it would also be a real. So that's kind of why this is written this way, is it makes it easy to understand. Your goal basically is to find the smallest subgroup that the number that you're given belongs to. And as you go up here, these are the smallest, and then this is obviously the biggest. It includes all the numbers. So let's talk about what a natural number is. A natural number are numbers that you count with. And so they would start with 1 and 2 and 3 and 4. Those are considered natural numbers. And then it keeps going after that. Now, if it's a natural number, that also means that it's a whole number, integer, rational, and real after that. But in the smallest group that it belongs to is a natural. And then we get into whole. And honestly, the only difference between those two is what number they start with. Natural numbers start with 1, 2, 3, 4, and whole numbers start with 0, 1, 2, 3, 4. So whole numbers only have one additional number, which is 0. Next, we get into integers. Now, integers, a lot of times people will confuse those with wholes. Integers are whole numbers. They include all the whole numbers, but they also include all the negative whole numbers. So if you had anything from like -3, then -2, -1, 0, 1, 2, 3, and then everything after that. Notice though, there's no decimals and no fractions, no square roots or anything in those. So if you're an integer, remember that means you're going to be a rational number and you'll also be a real number. Um, as a side note, all the numbers you've ever used in your entire life are real numbers. Let's go to rationals. Now, rationals are going to be the first place where we're finally going to see other numbers that could have decimals, could have fractions. So, for instance, a rational number would be 1/2, zero point 0.5, which is the same as that, 0.82. Now, one thing to keep in mind though, you can also have repeating decimals. So notice I wrote that point 0.3 with a line over top. That actually means 0.33333 goes on and on and on and on forever. So that's a repeating decimal. So fractions, terminating decimals, and repeating decimals all belong to the rational family of numbers. Irrational is going to be are going to be numbers that uh, the decimal can go on forever, or it could be a square root that is not a perfect square. So, for instance, the square root of 2, that's going to be a decimal, 1 point something, something, something goes on forever. Another irrational, very probably the most famous one, is pi. 3.14159, and then that keeps going on forever. So that's another decimal that does not terminate. So non-repeating, non-terminating. So non-repeating and non-terminating. And I apologize for my writing. It's hard to write on this iPad clearly. But non-repeating and non-terminating decimals. So non-repeating, and what I mean by that is it's not 0.33333333. If it's like that, if it 0.2525252525, that would be included in rational. Irrational are numbers that do not repeat and they do not terminate. They don't stop. Real numbers are all of the above. So they include all of the numbers that you see above. Real numbers are natural, whole, integers, rational, irrational, and real. So let's go over here, and now we're going to classify each of these numbers. So I'm going to use a highlighter. I think that's going to be the easiest for me. Just got to get a few more colors here. And we'll go with green. All right. I am going to erase one of these. I want to use these two. Those colors are a little too close together, so I'm going to use light blue for this. Okay, so let's go through and mark just the natural numbers first. Now keep in mind, natural numbers, if they're natural numbers, it means they're all the rest too. But you're always trying to get the smallest group that it belongs to. So remember, our natural numbers are 1, 2, 3, 4, 5, and up. So it looks like number 55 would qualify, and that's going to be it. That's all we got. So number 55 belongs to the natural numbers. Now let's move on to the whole numbers. So remember, the only difference between natural numbers and whole numbers is whole numbers include 0. So then we can highlight 0, and that's it. Now remember, if it's a whole number, then it's an integer, rational, and irrational. So we're just trying to find the smallest group that they belong to. And I see that I skipped one. There is another natural number here. 140 is also another natural number. So we'll get that one highlighted. Now moving on to integers. Now integers are numbers that are whole numbers, but they can be positive or negative. And so we've already classified some of those into a smaller group, but we still have a negative 18 right here that we need to classify. That would be considered an integer, as would negative 76. Now we're getting a little bit into a broader category of rational numbers. Now, rational numbers are going to be fractions, or they can be repeating. They can be repeating. Um, So we can see rational numbers can be fractions also. So you can see this is a fraction, this would be a fraction, this would be a fraction. Now there's a couple of these that are a little tricky and they're in disguise. They're going to belong to some smaller groups, but we're going to go back there. Now let's go to irrational. Okay. Now irrational is going to be any number that is not a perfect square if you try to square root it. So you can see there's the square root of 2. I use that as my example. So that's an irrational number. Now I'm looking at the square root of 31. That doesn't square root nicely. But let's look at the other two. So we have this number over here. I'm going to underline it for a second. We have the square root of 81. If you don't recognize that, the square root of 81 actually equals 9. That will simplify down to 9. And then what we realize is, oh boy, that 9 belongs to natural numbers. That's actually a natural number. So we're going to go back and re-highlight that with yellow. Put that back with its group that it belongs to. Looking at this other square root down here, I'm going to put a star beside it, that negative square root of 36. The square root of 36 is actually 6. So this number becomes negative 6. And when we do that, we realize, oh, okay, that's maybe not as complicated as we thought it was. It needs to be highlighted, and that would be an integer because it's a negative number, but it's not a decimal or a fraction. So we're going to highlight that as well as an integer. And I just highlighted it with the wrong color. There we go. There's our integer color. So the last one that we have here is going to be this one where we have pi. If you see pi, you automatically need to think irrational. So if there's a pi in the number, it's going to be an irrational number. So it's going to belong to that one right there. And there we uh, classified all of our numbers. Okay, now moving on, it says write point 4 repeating as a fraction in simplest form. So I'm going to show you a trick to this. If you have point 4, 4, 4, 4, 4, it means it goes on forever. The way you do that is you take whatever digits that are repeating, in this case there's only one, it's a 4, and you write it over that many nines. So point 4 repeating is 4/9. It's that simple. Now this one, this is 0.23. This is 0.232323. It goes on forever. It's actually repeating. So in that case, we take however many digits are repeating. There's 2, 2, 3, and you put it over that many nines. So that's 23 over 99. And that fraction, if you divided it on your calculator, would give you 0.23 repeating. And that is as far as I'm going to go for today. All right, guys, have a good day.